If it's more like the one up top, it's a rectangle with a 5 and an x and a 2 on the side. So to get my area of my top rectangle, what's 5 times x? 5x. And what's 5 times 2? 10. Okay, what other thing are you seeing right here, everybody, that we've seen before? Distributive property. So it is the distributive property. That's why these are the same thing. The area model proves the distributive property, which I think is pretty cool. I'm going to continue with this idea. We're going to use the same concept all day. So things are going to get like, there's going to be more to it, but same concept. So in this one that you're given, you're not going to do anything with this. It's just explaining what I'd like you to do. We're starting with the expression 4 times x plus 2. So here's my 4, and here's my x plus 2. And the area model could give me for these two little rectangles a 4x and an 8, which is proof that 4 times x plus 2 is the same thing as if we distribute the 4x plus 8. I want you to then make the extension and the jump to writing a diagram for n times 2n plus 5. And that diagram should show the distribution 2n squared plus 5n once we've done it. All right? So you're going to make the jump from here to here. There's more room on your notes to do this. And then who was the first name up on the flippity thing? Meredith. Okay, Meredith's going to show us hers in a moment. So Meredith's going to show us the diagram that she drew. And there's a rectangle. One side length is n. And the other is 2n plus 5. Okay. And then Meredith found the area of each one of those rectangles as 2n squared and 5n, which shows that it is equal to 2n squared plus 5n. I do want to show you another one I saw out there in the streets, okay? And this one is actually one I did in my notes as like, could students do another one? And this is the one that I saw out there. And it's kind of cool. I saw an n times n times or plus 5 times n. So that left side is a 2n plus 5. They broke down their n into n plus n there. And then that would give us an n squared, and a 5n still for 2n squared plus 5n. So that's the other way that you could kind of see it. I personally prefer the other way, the first way, just because it's like everything's a little already tighter. But this still works. So next, you're going to do the same thing with A, B, C, and D, but you're going to attempt to do it without the model. Just do the distribution instead of the diagram. But if you're feeling stuck, go to diagram. The 4 people, I'm going to put them up on Flippity. The next 4 people are going to do A, B, C, D in that order. All right, Livia. You can use that big open space, and I'm going to erase it for the next one. So, Livia's going to show us 6 times 1/3 n plus 2. No diagram this time, just distribution.
Oh, wait, it's on a, like, eraser.
See on the...
Is it?
Yep, right there.
This one?
Good job, Livia.
We got 2n plus 12. That works. Who's got B?
I'm really nervous.
It's all right, Cam.
We got this, Cam.
I feel like I'm going to drop it.
Okay, Cam's going to distribute the P.
Hold on, I forgot what I had.
I want you to copy what you had.
Wait.
You should be able, I think you just look at it.
Yeah, I don't want to, though. 4p squared.
4p squared plus...
That's a 9!
It's a 9. All right, who's next? Troy's up.
Troy's next.
It's a beautiful 9. I don't care what you say.
Cam,
It's
Thank you.
5r squared plus 3r.
That's the pirate's favorite one.
Yeah.
Did you know that?
No, I actually
It is. Because the R squared. Last one of these, D.
oh, no.
We got 1/2 W squared plus 7 W. Awesome. Thank you. So, as we have been doing, same concept, that area model and distribution, we're now going to apply it to a slightly more complicated polynomial. You're going to look at x plus 1 times x plus 3. I only want you to do number 1. I'm going to give you 35 seconds. Okay, so when I multiply all my areas, I'm writing with the eraser. X squared, 3x, x, and 3. When I combine like terms, I get the expression x squared plus 4x plus 3 which shows that these are the same. Your job next is to draw the diagrams for problem 2, A, B, C, D. The next 4 people on the list will be the next 4 people to show diagrams.
Good luck, Ivy.
Here you go, Ivy. We're looking at the diagram, the filled-in diagram. You're just doing that open space on the bottom. There.
Okay.
I'll erase it between. The number 1 wrong answer for this question is x squared plus 25. Well, watch the diagram and then you'll see.
Oh, I see.
X plus 5 times x plus 5 is what the function or the expression is, right?
Oh. Is that the right answer? Because I think I got it.
So, if you did it incorrectly, you're missing a whole 10x. If you have x squared plus 25, you're missing a whole 10x. That's the number 1 missed problem on the quiz coming up.
Now it's not going to be.
We'll see. We'll see.
Oh my god, I was right.
No, you
All right. I'm going to give everybody another minute to go look at B, C, D, and E in case they need to. You're up, Addie. Addie's up, everybody. Oh, I gotta get you a space here. There you go.
Okay.
Let's see this diagram for 2x times x plus 4. This one's going to look a little different. 2x times x plus 4. We got a 2x on one side. And we got an x and a 4 on the other. So when we get the 2 areas of these rectangles, what do we get?
Well,
2x squared and 8x.
do I need to write
There
this?
we go. Yeah, I'm going to rewrite the expression.
Wait, what? I have to do that too?
There we go. Who has C? Kai?
Yep. Alright, I got
All
this.
right. Let's get you some space here, Kai. You got this, man. Send the link to this to your grandparents tonight.
What? Alright, let's do this.
Okay. Wait, did I switch it back? Yeah, I did. Okay.
We got the
We're gonna
square.
see 2x plus 1 times an x plus 3 diagram next.
These are what's your
Alright, let's see. 2x,
Plus
1, x. Is it 3?
Kai, there's lines of this.
Wait, alright. 2x squared.
He's nervous. He's doing great. Keep it going, Kai.
Oh, that's beautiful.
Alright.
All right, so combine like terms. We have 2x squared plus 7x plus 3. There we go, Kai. We did it.
Oh, wait.
Bro said 8.
And D. Sophia. This one is like same concept. It's actually not harder, even though it just looks crazy.
Yeah.
So we got a little x plus m times x plus n action. Binomial times binomial again.
Like a...
So we got x,
Wait.
and n. Not the order I would have done it all, but it's still good. It's still good.
Right.
So x times x is x squared. X times n is nx.
Doesn't matter.
N times n is nm. X times n is xm.
Oh, feeling it.
So we're going to have 4 terms here. Any like terms?
No.
Like terms, same variable, same exponent.
Oh, I'm mom.
Right,
So we got x squared plus nx.
X, yeah. That's right.
plus-
How am I gonna fit
Go
this?
below, just go
Okay.
below. Plus and then there we go.
Good
Xm
job, Sophia.
plus-
I don't know how to do it.
There we go. Thank you, Sophia.
Yeah.
There is an opportunity you could like factor something out in the middle, but it wouldn't really simplify it any more than we need. Oh wait. Next, number 3. I want you to now do it without drawing the diagram. So same problems, binomial times binomial, no diagram. We've been practicing this for a little bit, right?
Yeah.
Elsa is going to show us how got 3a. X plus 2 times x plus 6. Let's see.
Okay, so I got x squared plus 6x.
So that's when you distributed the x. Okay.
Yep. And then I got plus 2x plus 12. And combined that would be x squared plus 8x plus 12.
Great. Hands is there. Next we got x plus 5 times 2x plus 10.
Oh, shoot.
concept is distribution, multiply everything by everything. That's what we did.
So should I write it underneath that?
Yeah, underneath that's great. You can
Okay.
go all the way to the left if you want.
So first off, there's 2x times x, so 2x squared plus the x's, so that would be, don't let me solve it, 10x from the x times 10, and then another 10x from the 2x times 5, so, oh, sorry, 20. That'd be 20x.
Total.
Yes.
So make sure you understand how Zeph got that 20x. The x times 10 and the 5 times 2 times x. That's 20x, okay?
And then, lastly, there's just the single numbers combined for 15.
Okay, but what property are we doing?
15?
It's 50.
We'll do multiplication.
It's multiplication.
So there's a little backwards tornado up there.
It's
you
fine.
can undo.
Chiropractor. You did good, Zeph.
Okay. Fifth. There we go. Thank you, Zeph.
Dude, I understand that.